Welcome to section 9.5, our final section. Now we're going to deal with quadratic functions. We've dealt with quadratic equations, now we're dealing with functions. So let's just jump in to kind of review and get some key terms out of the way. So let's review first and foremost. How do you find the x-intercept of a line? Now remember, that takes you way back to this is chapter 3. We found the x-intercept by setting y equal to 0 and then solving. Well, with that in mind, how did you find the y-intercept of a line? Remember, you set x equal to 0 and you solve the equation again. So these are going to be vital parts to what we're doing today, but another really important thing is remember that they are points. So they're going to have, so for instance, this one would have an x value with y is equal to 0. This one will have an x equals 0 and y is some value that when we solve, we're going to get it. So these things are used to find half the point, but they are points. Don't forget they are points. They're not numbers, they're points. So also to help you, we're dealing with a function. This is a function. So if I do f of 0, what am I asking you to look to do? Well, it means I'm going to plug in 0 for every single x. So 0 squared minus 4 times 0, well, those are all zeros, so that's just minus 5. So with that in mind, can you find f of 1? Go ahead. Well, hopefully you did it by plugging in 1 in all the spots where x is. We simply do the arithmetic, because 1 squared is 1. Negative 4 times 1 is negative 4. Then we do our subtraction, and we know with negative 8. Okay, what's f of 2? Go ahead and pause the video and find it. Again, we can start by plugging in 2. 2 squared is 4, and so forth and so on. Subtraction, I get negative 9. Okay, this is kind of nice. All right, what about 3? Go ahead and find that. Well, if you do the arithmetic again, you plug it in and then do the arithmetic. Right? 9's 9 minus 12 minus 5, which is negative 8. Oh, wait a second. So this is a function, but notice it just gave me the same y value for two different x's. Because remember, that is okay. It's just that no x can give me two y's. So this is perfectly legit. This is actually okay. So we're looking for this. We're just kind of trying to find these values. And this would actually give me 4 points if I was to mark these on a graph. And I can start using this to kind of get a better idea about what the graph looks like. All right, so let's look at some more just to get ourselves going. I want you to solve this equation. So we just talked about how to find a function. Now what if I have it equal to 0? How would you solve that? Well, remember, there are multiple ways you could do this. You can factor, you can use a quadratic formula, or you can complete the square. Let's use the quadratic formula, this IM. A is 1, B is negative 4, and C is negative 5. Because I just want to use the quadratic formula to reinforce this idea as one of our many tools. Well, with that in hand, plug everything in. So negative 4, negative 4 is positive 4, negative 4 squared is 16. Multiply that and I get plus 20. 16 plus 20 is 36. The square root of 36 is 6. And now I can break that up into the two different options. I got 4 minus 6 and 4 plus 6. All that over 2. 4 minus 6 as well. That's negative 2 over 2 and 10 over 2. So my answers are negative 1 and 5. So that was nice. We can solve it by using the quadratic formula or completing the square. They will always work, and factoring will work a lot of times too. All right, so let's move on to some key terms. What is a quadratic function? Well, it's a function that's of the form f of x equals ax squared plus bx plus c. Notice this is the standard form that we've seen everything else so far over quadratic equations. So it's very similar to our standard form. Excuse me. Now, something interesting about this is that these always have one of two shapes. They either do this upside down, this like U shape, or like an upside down U. These are called parabolas. And it's either one or the other, not both. It's one or the other. In fact, which one it is, opening up or opening down, depends on our A. If A is bigger than 0, so if this first number in front of x squared is bigger than 0, it's opening up. If A is less than 0, it's going down. Now, one of the ways that I can remember that is I kind of draw a smiley face. I put a couple marks here and I make a smiley face. And that's because I'm positive. If I use a frowny face, which is kind of, if you just put a couple eyes up here, it's got a frowny face. This means it's in a negative mood. That's just one of the ways I have to remember that. Well, along with this, there's something called a vertex. Now, what is a vertex? Well, let me just go back for a second. On this graph, see this one that opens up, you see how there's a kind of a bottoms out point, and here it has a peak point, gets the highest. Those points are the vertex. They're the lowest point or the highest point of a vertex, depending if it opens up or opens down. So it's a really important point on every vertex. And the equation we use to find it is, because again, it's a point, the x value is negative b over 2a. Now I'm going to pause right there and ask you, when have you seen that variables and so forth before? Hopefully you're realizing that's everything in the quadratic formula that's not in the square root. Wait a second, we used all the square root for the discriminant, so we get to break the quadratic formula apart into pretty much the vertex and the discriminant. But this is just going to give you an x value. Remember, this is a point, so I need a y value. So you literally need to plug in that x value into the original function. That's how you're going to get your y value. There's no super cool magic trick, to be honest. So with this in mind, let's just move on to some examples. So I want to work through how to graph these. So let's start with this one. I have x squared minus 6x plus 5. First, I want to find the vertex. So to find the vertex, we need to first find the x value. So remember, x equals negative b over 2a. So what is my b? It's negative 6. So I got negative 6 over 2 times 1 because a is 1. And a negative makes that a positive 6, so my x is 3. But I'm not done because remember, vertex is a point. So how are you going to find the y value? You can plug that x equals 3 in. Back into my function. So f of 3 is 3 squared minus 6 times 3 plus 5, or 9 minus 18 plus 5, which is negative 4. So our vertex is the point 3, negative 4. It's pretty cool. That's a nice, easy thing. Okay, next challenge I have for you, I want you to find the y-intercept. Now remember, I started off by saying the y-intercept is when x is equal to 0. So let's take our function and plug in x equals 0. Seems simple enough. You plug in x equals 0 and you got 0 squared minus 6 times 0 plus 5, or in other words, just 5. So I get the point 0, 5. I got 2 points. That's a good start. The problem is you need far more than 2 points to graph a quadratic function. So let's keep going. Let's find the x-intercepts. How do you find the x-intercepts? Remember we set y equals 0. Oh, wait, where's y? Oh, it's the f of x. So this is actually the y value. So I can replace that and I get 0 equals x squared minus 6. I'm going to pause the video and to solve that quadratic. Go ahead. Now again, there's a lot of different ways to do it. I factored it just because I knew it's factorable and I like factoring. And I can make it x minus 5 and x minus 1, which you break up into each side equals 0, and you end up with x is 5 or 1. But what that really means is I got 2 points. I got 5, 0, and 1, 0. So this gives me 2 points. You add that to the other 2 points, and put all of our points together. I got 4 points. Now can we graph them? I hope so. So let's first plot all the points. Pause the video and just plot all 4 of those points. All right, now if you did that, you should have come up with the points kind of looking like this. Now notice they're not in a straight line. This is definitely not a straight line, and this really is not a straight line. Because I'd have to go straight line like this or straight line, just ugly. So how are you going to do that? Well, a quadratic function, remember, is a kind of a U shape. The parabola is the lowest point. So this is the bottom. My leading coefficient is 1. The number in the very front of x squared is 1. So it has to be opening up because it's positive. So that means it's going to end up looking like this. If I play connect the dots and just kind of use it. Now you could have found more points if you really wanted to. As you can see, it goes through this point right here at 2, -3 and 4, -3. But you don't always know that. So just kind of play with this and you're going to get some things going on. If you look carefully, also notice there's a symmetry that this point is exactly the same distance from the x value of the vertex as this is from the x value of the vertex. So in other words, this one's over 2 this way, this one's over 2 this way. If I come up here, this one's 3 over. If I go 3 over the other way, oh, look, it hits. So there's this nice symmetry of all these, and that's why parabolas are very useful. All right, so I'm going to pause the video. I'll continue it in the second part, going through more examples about how to graph these.